morning. So today I am going to discuss about semiconductors. Okay, semiconductors. Then we will be discussing some of the properties of insulators and conductors. Okay, so mainly we will focus on semiconductors. So yesterday in previous lecture we have discussed molecular orbital theory, or we say band theory. Okay, and I told you according to band theory there are the electrons, okay, atomic orbital combines to form molecular orbital. Okay, and these molecular orbitals, okay, are means if n number of atomic orbital combines, then molecular orbital form are n. So there are so many molecular orbitals formed, okay, that the energy difference between these molecular orbitals are we say very less. Okay, and due to this what happens, they begin to blur. Okay, and they are not going to present any distinct view. Okay, so what happens, they seems to be present like band. Okay, like layers of a band. Okay, so today I am going to discuss, okay, these bands are of two types. One is called valence band and one is called conduction band. Okay, so there are two types of band. One is known as valence band. Okay, this is known as valence band. And this one is known as conduction band. So what is valence band? Valence band, okay, is that band where electrons are present. Okay, or we say the occupied band is known as valence band. So in valence band electrons are present. In valence band we say electrons are present. Okay, and in conduction band we say it is empty. Conduction band is empty. Okay, and valence band and conduction band is separated by a gap. This one is gap between valence band and conduction band. Okay, so valence band is that band where electrons are present. Okay, and conduction band are those band which are empty. Okay, and these two bands are separated by a distance, a gap. Okay, so this is a gap, means gap between valence band and conduction band. Okay, so what happens when it comes to electrical conductivity? When we say electric current is applied, then what happens? Electrons from the valence band, okay, gets energy. Okay, and due to that energy, that extra energy, it jumps from valence band to conduction band. I told you conduction band it is empty, valence band is filled with electrons. So as electric field is applied, what happens? The electrons present in valence band, okay, gets energized, and it jumps from valence band to conduction band, overcoming this energy gap. Okay, overcoming this gap. Okay, and due to which what happens, it starts conducting. So conduction is due to the presence of conduction band. This conduction band, okay, accept electron coming from valence band and it contributes towards conduction. That's why this one is known as conduction band. Is it clear? So as a whole we will say there are two types of band. One is valence band and other is conduction band. Valence band is that region where electrons are present, or we say occupied band is known as valence band. Conduction band is that band, okay, which is empty. Okay, but what happens when electron jumps, okay, from valence band after means getting energy, okay, then the conduction band accept that energy, and during this process movement of electron or flow of electron takes place, and which results in increased conductivity of the material, and that's why it is known as conduction band. And valence band and conduction band, okay, have some gap between them, okay. So now we are in the position to discuss conductor, insulator and semiconductor. So we have three things. One is conductor, okay, then say it is insulator, and then it is a semiconductor, okay. You all know about these things, very basic things. What are conductors? Which allows electricity to pass through it. What is conductor? Which allows electricity to pass through it. What is insulator? Insulator we will say which do not allow passage of electricity. Insulator means which opposes or which do not allows okay, which do not allows electricity to pass through it. Electricity to pass through it. And semiconductors, okay, semiconductors are in between a conductor and an insulator. So we say it is in between a conductor and insulator and an insulator, okay. Means the conductivity, okay, is less than the conductors and more than the insulators. This is very basic thing. Now we will say what happens in case of conductor, okay. Conductors are supposed to be good conductor, okay, when we say conductors are good conductor when their conductivity range is in between 10 to the power 4 to 10 to the power 7, okay. So what happened, I told you, in case of conductor, a good conductor lies in the conductivity range from 10 to the power 4 to 10 to the power 7 ohm inverse meter inverse, okay. So a good conductor will be only those conductor, okay, which have a conducting range from 10 to the power 4 to 10 to the power 7 ohm inverse meter inverse. Now in case of insulator, what happens, the conductivity range is in between 10 to the power minus 20 to 10 to the power minus 10 10 to the power minus 22, 10 to the power minus 10 ohm inverse meter inverse. And in case of semiconductor, the conductivity of a semiconductor, lies between 10 to the power minus 6 to 10 to the power 4, 10 to the power minus 6 to 10 to the power 4 ohm inverse meter inverse. Got this? So this is the conductivity range of these three. Now come to the most important point. What happens in case of conductor, insulator and semiconductor? I told you there are two types of band. One is valence band and other is conduction band. Okay. So in case of solids, what happens? If it is valence band, I told you valence band are those band, okay, means where electrons are present. So this band is filled. And if this is conduction band, this is conduction band. I told you conduction band is empty. Conduction band. In short, we can say valence band as VB. Okay, valence band as VB and conduction band as CB. Okay. So this is empty. I am writing here. This is empty. And I told you in between valence band and conduction band, okay, a gap is there. So this is the gap. This is the gap, okay, between VB and CB. Between VB and valence band and conduction band. Getting this? Two things. One is valence band and other is conduction band. And I told you there is a gap between this valence band and conduction band. Okay, this is in case of conductor. Okay, now I am drawing in case of insulator. Okay, then after drawing I will make you understand. So what happens in case of insulators? Again, one is valence band. So say this is VB, valence band, and I told you valence band is occupied. So this is occupied, okay. And in this case, say this is in conduction band. This is conduction band, and I told you conduction band is empty. And you can see here between valence band and conduction band there is energy gap. There is a gap, or we say this is energy gap. This is energy gap between valence band and conduction band. Okay. Now come to in case of semiconductors. So say this is valence band. Again I told you if it is valence band then it is occupied. So this is occupied, means electrons are present. This is valence band. And say this is conduction band. This is conduction band which is empty. And this is energy gap. Getting this? So I think now you can understand by yourself. Okay, what means what is the meaning of these three figures. Okay, come to the first case. In case of solids, what happens? Valence band and conduction band, okay, are separated. Okay, means by, we say it is almost negligible gap. Almost it is negligible gap. So in case of solids, we say valence band and conduction band, okay, are overlapped, means are overlapping. Okay, in state of overlapping means they are so close to each other, okay, that we can say they are overlapped. They are overlapped. You can see here this energy gap, and this is, we say, very small energy gap. Okay, so what happens? Energy gap is small, so by absorbing a very less amount of energy, the electrons present in valence band are capable to jump from valence band to conduction band. Getting this now? If energy difference between valence band and conduction band is, we say, a least, okay, minimum, then what will happen? By absorbing little amount of energy, the electrons which are present in valence band will jump, okay, jump towards conduction band, because energy gap is very less. Okay, so you can simply understand it by yourself. Okay, suppose you have to jump 1 meter. Okay, so very easily you can jump 1 meter, okay, by less effort. Suppose second time you have to jump 2 meter. Okay, then you have to take run up. Okay, and suppose if you have to jump 3 meter, then you have to take long run up. Means if you are you have to cover 3 meter distance, okay, then you have to jump with high energy. Getting this now? So energy required is more, means if gap will be increased, then the energy, the effort you are putting, okay, will also be more. Getting this now? So same thing is happening here between valence band and conduction band. The energy gap, okay, the gap is very small. So by absorbing a little amount of energy, electron present in valence band, okay, jumps, okay, in conduction band, and the conduction starts. And that's why conductors are, we say, means they are very good conductors. Why they are good conductors? Because the energy gap between valence band and conduction band is almost negligible. Insulators. So what happens in case of insulators? The energy gap you can see here. Okay, you can compare these three. This is energy gap, and here energy gap in case of semiconductors, and in case of insulators. So energy gap is quite high, quite large. You can see this. This is the energy gap, and you can see this is quite large. So for electrons present in valence band, it is very difficult, okay, to jump from valence band to conduction band, because they have to cover a lot of distance. Okay, means to jump from valence band to conduction band, okay, they have to cover a big distance. Okay, so more energy will be required, and that's why it is not possible for the electrons present in valence band to jump, okay, in conduction band. And if electrons are not capable of jumping, means electrons will not flow, and if electrons will not flow, then it will not conduct, or we will say if it is not conducting, then it is insulator. Okay, now come to semiconductors. What happens in case of semiconductors? The gap between valence band and conduction band, okay, is in between solid and is in between conductor and insulator. So this gap is neither too big, neither too small. Getting me? This gap between valence band and conduction band in case of semiconductors is neither too big nor too small. Getting me now? So some of the electrons are capable of jumping from valence band to conduction band, okay, but all of the electrons are not capable of jumping from valence band to conduction band. So the conduction in case of semiconductors is less than conductor, okay, but more than insulators. So this is all about conductor, insulator and semiconductor. Okay, now we will be discussing semiconductor in more details. Okay, so our topic is next topic is semiconductors. Okay, so I am rubbing this. Next topic is semiconductor. So put heading, it is semiconductors. So what are semiconductors? Semiconductors, we say group 14 elements. Group 14 elements. Okay. Group 14 elements like silicon. Okay. Silicon, germanium, etc. Silicon, germanium, etc. are known as semiconductors. Okay, group 14 elements, okay, like silicon, germanium are known as semiconductors. Okay, then what happens? I told you in case of semiconductors, what happens? The conductivity lies in between a conductor and an insulator. Means it is not a good conductor. It is not considered as good conductor. It is a good conductor as compared to insulator. But when the comparison is with conductors, then it is not a good conductor. Okay. So what happens when you will heat? Okay, when you will heat a semiconductor, then its energy, sorry, then we say its conductivity increases. Then its conductivity increases a little bit. Means what? I told you in case of semiconductors, two bands are present. One band is known as valence band, in which electrons are present. Other band is known as conduction band, which is empty. Other band is conduction band, which is empty. Okay, this is conduction band. Okay, and there is energy gap which is in between a solid and an insulator. So if we are hitting the semiconductor, what will happen? The electrons which are present in valence band will acquire, okay, acquire extra energy, will get extra energy. Okay, means kinetic energy of the electrons present in valence band will be increased. And what happens? This extra energy, okay, this extra energy, due to this extra energy, the electrons which are present in valence band will start, okay, jumping, okay, and will jump to conduction band. So this if we will heat a semiconductor, then electrons will get extra energy, and the rate of, we say, means jumping of electrons will be increased. And if more electron will jump towards conduction band from valence band to conduction band, then we will say conductivity is increasing. And that's why I told you, when a semiconductor is heated, the electrons present in, okay, when a semiconductor is heated, the electrons present in valence band gets extra energy, and Due to this, their kinetic energy increases. Due to this, their kinetic energy increases. Okay. Due to this increased kinetic energy, jumps from conduction valence band to conduction band. Hence increasing the conductivity of the semiconductor. Getting this point? Okay, if you will heat a semiconductor, then what will happen? The electrons present in valence band will acquire some extra heat energy, and due to this their kinetic energy will be increased, and due to this increased kinetic energy, it will result, okay, in jumping of more electrons from valence band to conduction band. And if more electrons will jump from valence band to conduction band, then conductivity will be increased. So I told you, when we heat a semiconductor, then its conductivity increases. Okay, but what happens? This increment in conductivity is not not enough. Okay, means it is okay that when semiconductor is heated, then its conductivity increases. Okay, but this increase in conductivity, okay, is insufficient for our use. Okay, so to increase conductivity of a semiconductor, okay, doping is performed. So this is very important thing I am going to discuss. Okay, so it is doping, and I am going to rub this. So just try to understand doping. What is doping? Doping is the process of mixing impurities to the semiconductor okay, doping is the process of mixing impurities to the semiconductors to increase its conductivity up to desired level. Okay, or simply you can say to increase its conductivity. Okay, up to desired level, it is okay, but you just write like this. Okay, what is doping? Doping is the process of mixing impurities to the semiconductors to increase its conductivity. Okay, I told you semiconductors are group 14 elements. Okay, so group 14 elements, okay, these are semiconductors. Okay, and I told you to increase their conductivity, okay, some impurities are mixed. So the impurities mixed are of two types. First thing we will say, just before group 14, group 13 is present, and just after group 14, group 15 is present in the periodic table, group 15. So group 15, okay, means valence electrons is equal to 5. Okay, Group 13 means valence electron is equal to 3. Okay. Group 14 means valence electron is equal to 4. Okay, is equal to 4. So very basic thing. Okay, if group 13 elements, if you will take consider any group 13 element, then the outermost electrons, okay, the outermost electrons present will be 3 in case of group 13, 5 in case of group 15, and 4 in case of group 14. If you are getting confused, then I am giving you one example. Okay, say if it is aluminum. Okay, then if it is aluminum, then what happens? Aluminum atomic number 13. So atomic is its electronic configuration will be 1s2, 2s2, or simply write in this way. We say 2, 8, 3. 2, 8, 3. 2 plus 8 plus 3, 13. Here it will be 2, 8 plus 4. Say if I am considering silicon. So outermost electrons are 4, outermost electron are 3. Say I am considering phosphorus, 15. So 2, 8, 5 means outermost electrons are 5. Getting this now? Okay. So what happens? Impurities are nothing. Impurities are simply group 13 and group 15 elements. The impurities which we are going to mix with group 14 or semiconductor is group 15 or group 13. So once group 14 element is doped with group 15 element, okay, or group 14 element is doped with group 13 element, means doping can be done in two ways. Okay, one way is to mix semiconductor with group 15 element, other way is to mix semiconductor with group 13 element. Okay, getting this now? Okay, now I am giving you example. Okay, when group 14 element is being doped with group 14 elements, sorry, group 15 elements. Okay, so what will happen? So let's see. So put heading, when group 14 element, when group 14 element are doped with group 15 elements, okay, or group 14 uses simply semiconductors. So when semiconductors are doped with group 15 elements. Okay, so I told you semiconductors are group 13 elements. Say it is silicon means 14. Okay, and I have told you outermost electrons or valence electrons are 4. So one silicon means 4 electrons are present. Okay, so if it is silicon means many atoms of silicons are combined together in this way. This is silicon, okay, say this is other silicon, say this is other silicon. Okay, so silicons have 4 outermost electron. Okay, so their valency is 4, means one silicon is, okay, bonded with 4 more silicon in this way, with 4 more silicon in this way. Getting this now? Okay, again here this silicon is attached with this like this. Okay, Okay, so just consider this silicon. So you can see very clearly this silicon have four outermost electron, four valence electron, and all these valence electrons are satisfied by making covalent bond with adjacent silicon. Getting this now? This is silicon. So what happens when it is doped or when it is mixed? Doping means simply mixing. Okay, so when it is mixed, okay, with group 15 element, I told you group 15, say phosphorus. So if it is phosphorus, then I told you it is 285, means 5 electrons are present in their outermost shell. So what happens if it is doped with silicon? If it is doped with silicon, means silicon plus plus phosphorus, then some of the silicon atom is replaced by phosphorus atom. Getting this now? Some of the silicon atom is replaced by phosphorus atom. Okay, so what happens? So we say here phosphorus, okay, is present, one silicon is removed. Oh sorry, big mistake na, this is not sulfur, silicon Si. Okay, this is Si, silicon. Okay, all are silicon. Okay, so here it is silicon Si, 4 electron, silicon 4 electron, again it is silicon 4 electrons, silicon 4 electrons, silicon 4 electrons, silicon again 4 electrons, okay now. Okay, so what? Phosphorus have 5 electrons in their valence electrons. So 1 electron, 2 electron, 3 electron, 4 electron. Okay, and 1 electron say here. Okay, okay, now what will happen? Just look carefully. Okay, all 4 valency of phosphorus will be satisfied with adjacent silicon. Okay, adjacent silicon. Okay, but here it is an electron which is still free. Okay, connect these. Okay, getting the difference now. Initially it was silicon. Okay, so all the 4 electrons were, okay, bonded by covalent bond with neighbor, okay, silicon atoms. Okay, but when it is doped means some of the phosphorus, okay, replaced silicon from silicon lattice. Then what happened? We know phosphorus is having 5 electrons in their outermost shell. So 5 electrons, 1 2 3 4 and 5 electrons. So 4 of the electrons, okay, got bonded, okay, got satisfied. This got satisfied. Okay, this got satisfied, this got satisfied, this got satisfied, this got satisfied, but this electron, okay, is still free. So what happens? This electron can move. This electron can move in the lattice, and due to the movement of this electron, okay, this we say becomes more conductive. Okay, getting this now? So due to the movement of this extra electron in case of when silicon is doped with phosphorus, what happens? I am writing here. Due to the extra electron present, okay, which is free to move, okay, the electrical conductivity of doped silicon increases. Okay, next point I am going to write, this increased conductivity is due to presence of or due to movement of free electrons, therefore this is known as n-type semiconductor. N-type semiconductor. This is very important. Okay. This increased conductivity is due to movement of free electrons. Therefore, this is known as n-type semiconductor. Getting this? So there are two types of semiconductor. One is called as n-type semiconductor and other is p-type semiconductor. So I am teaching you n-type semiconductor here. So what is n-type semiconductor? When a semiconductor is doped with group 15 element, okay, then what happens in the lattice of the semiconductor? What happens when semiconductor is doped with group 15 elements? Then some of the atoms of semiconductor are displaced, okay, or replaced by group 15 elements, and we know group 15 elements have 5 outermost electrons present, okay, on their atom. So 4 of the electrons present, okay, are satisfied, okay, or makes covalent bond with 4 of the electrons of silicon, but 1 electron is present as extra electron, and due to presence of this extra electron which is free to move, okay, the conductivity of a semiconductor, okay, when it is doped with group 15 element increases. And due to the increased conductivity, okay, we say this increased conductivity is due to the presence or movement of electrons. So this is known as n-type semiconductor. N-type means negative type. N-type means negative type semiconductor. N-type means negative, and electrons are negative. That's why, okay, these are known as negative type semiconductor or n-type semiconductor. Okay. So now it is p-type semiconductor. Come to p-type semiconductor. P-type semiconductor. So what happens in p-type semiconductor? Semiconductor is doped or mixed with group 13 elements like we say aluminum, we say gallium, okay, like gallium etc. So I have told you earlier, group 13 elements have 3 outermost electron. Okay, so what happens this time? a group 13 element replaces silicon atom from its lattice. Okay, so say this time it is gallium. So group 13 element have only 3 electrons, in their outermost shell. Okay, so all of these 3 electrons will be satisfied, will form bond with nearby silicon atoms. But what happens, there will be a vacancy, okay, at fourth place of electron. Means there will be a hole present at the fourth electrons, because only 3 electrons are present in case of gallium. Okay, so this hole can be occupied by the electrons which is present nearby. So this electron will occupy this hole, and due to which what will happen, at this position a hole will be created. Again, say this electron is going to occupy this hole, then at this place one hole will be occupied, hole will be created. Say if this hole is occupied by this electron, then at this place one hole will be created. Getting this? So what happens in this case, movement of hole takes place, and due to movement of hole, okay, it is simply we can say here movement of hole is taking place. Okay, so hole means positive, okay, hole means lack of electron, means positive charge. So movement of hole due to the electricity here is conducting due to movement of hole, and that's why this type of semiconductors are known as p-type semiconductor. P for positive type semiconductor. Positive is for hole is considered as positive, because here conduction is due to the holes present. Okay, that's why these are known as p-type, positive type semiconductors. Getting this? So these are known as p-type semiconductors. P-type semiconductors. Okay, so in our next video we will be discussing magnetic behavior of a solid. Okay, and I think our next lecture will be probably the last lecture of this chapter. Okay, so in next lecture we will simply finish this chapter. Okay, and then we will go ahead, we will move to second chapter, solution. Okay, so one more lecture is there, okay, for solid state. Okay, thank you.